Okay, everybody, welcome to class tonight. Topic tonight is FPP Advanced Settings. Ron Armstrong's going to give us his wisdom and some of the advanced ways that we can set FPP up to do a few more choice fun things. Ron, take it away.
Thank you. I'll go ahead and spot for everyone. This is Ron Armstrong. For those that don't happen to know me yet, been around the lighting hobby since about 2018. Been a very active Zoom room helper in here for a number of years, multiple thousands of hours spent in here. Um, Also been fortunate enough to be invited to be part of the testing and QA team for FPP for the last 2 years. So very excited about being able to work and help test and make sure things work the way that they should when it gets released. We know everything's on a rapid development cycle, so things change rapidly. Tonight, we're going to go over a couple of the things, more advanced topics in FPP. We've had several classes on FPP recently that are posted in the YouTube channel for xLights Gems. So feel free to reach out and view those videos for any content that won't be discovered today. The topics we're going to cover today are certainly not going to be applicable to everybody's show, but we just wanted to kind of demonstrate some of the other features and functions that FPP is capable of. We kind of titled it as advanced topics. We do have several helpers in the room that will be watching chat. If you have any questions, feel free to post them in chat. And for the sake of the video, I may repeat those questions just so for those that are not here live, they'll be able to see those questions and answers as they come up. So we'll go ahead and kind of jump in. The content we've kind of based on, let me go ahead and share my screen as well, get that kicked off. A lot of the content we've kind of based on, various, things that we've run into in the community support program, whether it's through Facebook or other messaging, or whether it's through the forums or even xLights Zoom room here. Things that people have done in the past or struggled to do, and there's not a lot of great detailed content on it. It's not intended to be completely exhaustive. So I want to point out here, I'm looking at the FPP manual. So from any FPP instance, if you go to help and then FPP manual, you'll be brought up to the FPP manual for that specific version that you're on. So that's a great resource to have. In my demo today, we're going to be talking about 4 different FPP instances. 2 of them are on the current 6.3.1. And 2 of them are actually on some of the 7 master for the upcoming FPP 7 release. Just so happens that they were already loaded with 7 master. We're not going to talk a lot about those differences because a lot of that was covered last week. And that video is available in YouTube. One of the things that have come up a couple of times recently is around networking, right? So there's several different standard topics of networking. I'm going to start in the manual. Let me flip back to my manual page. And in the table of contents, you can scroll down a little bit, and it happens to be in the FPP 6 manual, page 162. And there's network consideration section down here and common network setup. So we'll just briefly touch base on some of the common network setups. Then we're going to get into an advanced network setup that's possible. If you click any of the links here in the table of contents for the FPP manual, there are quick links to take you to that section. So if you just click there, it takes you right to that page. So the 4 primary methods of networking with FPP and shows is either a standalone, which means you have a self-contained show that doesn't connect to the internet or any other devices. We have, and that picture kind of looks like this is on the manual, so I'm not going to go in detail. So like a switch, maybe FPP is your player and you got your show computer and then controllers, but it doesn't connect to anything else in the world. That's just standalone. We have home network setups where your controllers in FPP may plug into your home router. This is very feasible, but depending on your show, that may not be terribly advisable. So there's a variation of that is with a switch. So home network with the switch. Again, if you already have FPP, you can review this manual. This is what we discussed a couple of weeks ago when we did our FPP basic as a show. And I've got that diagram up here real quick. So this is what we talked about a couple of weeks ago So this is a representation of that home network setup with the switch. We have an FPP device plugged into a switch with a controller. And in this case, I had a separate FPP device running some panels that is Wi-Fi doing FPP remote or multi-sync remote. Talk more about those details in a little bit. So this is kind of what I'd set up for a demo for that class, and we're going to expand upon that today. But a big one that a lot of people revert to is this separate show network setup, right? And that's an example where you might use an FPP device as kind of a network connecting device to connect your home network and then directly connect to a controller, either a singular controller or multiple controllers. So this picture here that we're showing on screen would be an example of multiple controllers plugged into a switch with FPP, and then the FPP actually bridging those networks between the home network where your show computer is into the show network. So that's a way to wirelessly enable your show network in case you can't get cables run. A little bit more complex of a network setup, but we see this network design very frequently. We're going to expand upon this design for today's conversation. So when you set up a separate show network like this, there's two ways that your xLights computer can access your controllers. The original way was you had to set up routing and static routes on your computer to be able to communicate through the FPP device to reach the controller. Sometimes that's complex on setting up static routings, and you get into these IP addresses and IP address 1 versus IP address 2 and what's what, and it can be confusing. For those who are interested in more detail on networking specifically, we're going to have a class coming up in August on just basic networking, and to not necessarily show specific, but we'll talk about IP addresses and what makes an IP address valid for one network versus another. So just look forward to that content coming out in a couple of weeks. Can't remember exactly the date, but anyway. So there are several people that might have their controllers spread all over. Maybe this wired to the controllers to a same switch may not be feasible. So they want to run multiple FPP devices and do this proxy method. I'm going to stop for a second because I didn't talk about the second method. So the one method of communicating is over routing. So knowing that that's more complex to set up and more confusing for people who don't have a networking background. So in FPP, they developed some years back a proxy method that allows you to do a web proxy to the controller. Much easier to set up. All controllers don't necessarily work great behind a proxy, but all modern controllers do. So if you have some very legacy controllers, as an example, a SANS device may not work great with the proxy mode configuration because it's really doing a web proxy for access in the web page of the controller. And it really depends on the specific controller whether that works well. So there's the proxy method, which is easy to configure, but not necessarily ideal for every controller type. Or there's the routing method, which is more complex, but certainly will work with any controller type. So the topic has come up a couple of times. What if I wanted to do multiple of these proxies? And so I put together this diagram to represent that. So in this scenario, you might have, realistically, you're going to end up with multiple show networks. So in this example, pretty simplistic, we've got a main pi that will be the player of the show, and he'll be your player with multi-sync and sending out the multi-sync protocol to your other FPP devices that will be operating in remote mode. And then each of these devices would be responsible to outputting to their connected controller, whether that's directly connected to a controller, such as I've drawn here with this Falcon 16V4, or directly connected to a controller. This one here is like a Genius, or even multiple controllers, such as this third one over here in this picture is connected to multiple controllers through a network switch. So it can be any mix of controllers in your show. So we're going to talk a little bit about using multiple proxies, because this is a more advanced, complex topology that may work for your environment, or it may not be great for your environment. Yep. And John posted in there that the networking class is August 9th. So August 9th will be a base network class. And so I took this concept to kind of evolve this demo network that I created for our earlier FPP basics and our details today. So this is a diagram of what to get set up now. So I got the same main player. He happens to be plugged into a switch, plugged into the Wi-Fi router. He could be Wi-Fi on his own as well. My little, lightning bolts here represent Wi-Fi and the lines represent network. And he's going to play to multiple FPP remotes. Starting on the left over here, this guy's going to be communicating to my Falcon in the lab. The Falcon happens to have a bunch of pixels on the table, followed by, this is a WRGB 20-watt flood that's on the table. So we got pixels connected to a flood, and he happens to be connected to a DMX controller. This is a dumb RGB DMX controller outputting to a DMX flood. These floods are side by side on my table. You'll see those when we get to turning the lights on and seeing some things. This bunch of pixels on the table is kind of representative of the outline model I have in my sample show directory I created. Then we have a second, and you'll see here that this is the 103 show network. So when we start looking at the FPP, we'll see that this show network is dedicated from this Pi test 3 to the Falcon, and his IP addresses will be 192.168.103. And then this Pi test IP test Pi 4 will be connected to my Dragon controller that we used a couple weeks ago that is outputting to my trees. You can see that in the camera. Yep, I'm going to mark that. I just looked up at the camera. So my video should be spotlighted. So for those, you might have to switch back and forth a little bit, but we have a camera set up showing the setup that we have here. So you'll be able to see the actual live view of pixels blinking. And then we have just leftover from last one. So I have this Raspberry Pi Zero, which is controlling my P10 panels. Then I have an xLights computer, which is the one I'm speaking to you on, that's wirelessly connected. So all of these are wirelessly connected to a router, except for the main Pi, which happens to be Ethernet connected. Everything in this upper section here, I want to draw a little bit. Everything up here happens to be in a single box. I've got it all mounted up in like a 50 cal ammo can. This is what I call my portable show in a box. So that's why I just left this connected, because it's all connected together in that ammo can. It's my portable show box that I use for a couple of demonstrations. Any quick questions on the overall topology? I know we went over that pretty quick. I want to get in the real meat and potatoes. Any quick questions on the overall topology? I take that as no. So let's go ahead and flip over
I'll
to
ask a quick one for you, Ron.
Sure, go ahead.
I was under the impression that it was not a great idea to depend on Wi-Fi for running a show, as there can be, latency and connectivity issues or reachability issues to devices.
Correct. So ideally, we don't want to shove or present active show network data over Wi-Fi. Wi-Fi can be finicky. Everyone's Wi-Fi is going to be different. It depends on your area, on how much noise you have, how much your neighbor Wi-Fi is overlaps, what channels they're on. So there's a lot of variability in Wi-Fi. If you do have a dedicated Wi-Fi network, then you have less of those problems, but it may be on a similar channel to your other Wi-Fi network. So you actually may be creating more problems. In this demonstration, what we're doing here is we're using the multi-sync protocol. So we're not sending E131 or DDP data over the Wi-Fi. So it's not as time critical for that latency or for that gap. So basically, it will do multi-sync to all of these other FPP instances, these Pis, and they'll get the start command, and then they'll get the sync commands every period of time to say you should be at this sync time. And then they get the stop commands. So the amount of traffic going over Wi-Fi is just really those sync packets from the multi-sync protocol.
But the gotcha there.
The multi-sync works rather well.
extremely, because it's very lightweight data. And if you miss a multi-sync packet, because each of these FPP instances, and we're going to demonstrate that, will be playing their own copy of the sequence. So he'll have a copy of the sequence playing out to this controller, copy of the sequence playing out to that controller, etc. So the only thing that they receive over the Wi-Fi are the start commands and then the sync commands saying you should be at this point in time. You should be at this point in time. If one gets missed, your show doesn't really skip, but maybe you get a little bit of skew, but then the next sync packet that comes in will adjust that skew so everything's back on the same time. Hopefully that helps you answer the question of why Wi-Fi. But yeah, traditionally we don't, again, everything we talk about today are options and things that could be done, not necessarily the way you need to set up your show, right? The right topology is the one that works based upon your show and the challenges you may need to overcome based upon your physical topography of what you have where in your show. So my network address spaces. So here in xLights, we'll just talk a little bit about. So 192.168.30 is represented by home network. Now yours might be .0, .1, or some other number. In my scenario, everything that's on .30 is representative of that Wi-Fi router we just talked about. So this Wi-Fi router and this network presented here is the .30 network. So there's nothing different on configuring these FPP devices that happen to be controllers that are connected there, right? We'll talk about this test pi 3 in a little bit, and you'll notice test pi 4 is not here. We'll talk about that too, but let's go to like the Dragon as an example. So when you're using the proxy method, you configure in xLights the actual controller IP address, the real IP address of the controller, and you also have to configure the proxy IP host name. So in this case, the FPP that is in front of that Dragon, his address is this 30.170. To review that real quick, you'll see that the Dragon is like on the 101 network. 101.102 is what it happens to be. And then the Wi-Fi side of the Pi that the computer talks to is 30.170. And so that's configured here when you set up the Dragon controller. The test by 0 is the one running my LED panels, and there's no proxy or anything related to him. He's just sitting over here running. He's waiting for his multi-sync commands in remote mode, and he's just sitting here waiting and listening for the data for the panels to when to start that sequence and stuff. And then the Falcon is set up as a proxied controller as well, and he's behind a different one that's 30.104. So again, we're talking about multiple proxies here, not a singular proxy. If it was a singular proxy, this would be the same IP address as it is for the Dragon. Hopefully that's not too complex really quick. So let's go ahead and fast forward to the FPP pages.
And what's the reason for going to multiple proxies as opposed to a singular one?
So there are some shows, I'm going to draw on the screen real quick just so we can kind of demonstrate that, right? So it depends on your layout, right? I'm going to draw a little bit. Let's say that I have a show that is super spread out, and maybe there's a retaining wall or some sort of obstruction, right? So in a typical show, you might set up like a network switch, put that as an S, and have a controller over here, and a controller over here, and a controller over here, and a controller over here as an example. Maybe these all connect to the switch, right? And then maybe you have your FPP device here, which is FPP, and he's Wi-Fi connected out to your Wi-Fi network because you can't get a cable out there. But let's say you have some obstruction, such as like this retaining wall I kind of drew in there real briefly, and maybe you can't get these network cables to connect, right? But you want to still be able to get to those controllers. So let me turn my drawer back on instead of the eraser. So you might put like another network switch over here that has your controllers connected and a second FPP device, F. And I'm drawing with my mouse, so I apologize for the Scrabble, but hopefully it makes sense. And then this guy's Wi-Fi connected also. So this would be an example, just depending on your topography and what you have in your show area as to where, whether or not you may need to implement multiple proxies, right? Because maybe you can't get a cable from this left side to the right side. There's a show I assist with locally for the last couple of years. It's in front of City Hall, and it takes up like half a city block in front of the hall. And there's sidewalks and like a little bit of a courtyard in the center of the building, and the mega trees in the courtyard. And we've got stuff all up and down there, and also to help reduce cabling crossing sidewalks. So, maybe another example is this is a sidewalk that's a high traffic and you don't want cabling to cross, and maybe you can't tunnel under it. So maybe there is not a feasible way to get that cable connected between the two halves.
And a lot of the reason for the multiple is because he's bridging from the FPP wirelessly to another controller, and each one is standalone. If he had all those others connected via a switch, you would only need one proxy.
Correct.
But because he has several players in remote locations, all being used Wi-Fi, you have to have, they're basically all separate networks. So you have to have separate proxies.
In these scenario, right, that specific we're talking about. So Rick's absolutely right. You can have multiple players, whatever. These are actually remotes, right? So this would actually be a remote with a single player. So FPP remote with a single player that is now controlling those remotes. So it's still part of one show. So certainly it could be a need for multiple players, or it could be a singular player, but you need to be able to talk to remotes that are not able to physically connect together with other controllers. If I flip back to this diagram, and I'm going to see if I can temporarily clear that. I can probably bring that back later, I hope, clear my drawings. So just imagine like this Falcon with his lights is in one location and the Dragon's in another location. I can't get wires to my network switch. That would be an example use case of where you might end up needing to do multiple proxies. And this came up like twice in the last couple of weeks with other people. So I thought we'd just get a presentation on what's possible, not that it would necessarily be required, right? Our recommendation is always the simplest method possible, right? Connect everything to a switch, your xLights computer, your player, all your controllers to a singular switch, or if you need a pair of switches, great. And then just keep it simple, right? One singular network, don't worry about it, no complexity. Tonight, we're talking about the state of possible and what we do see sometimes in the field. So our original question answer, did that tend to answer the scenarios on where you might want that?
Yep, perfect. Thanks.
Yeah, waiting for wireless power. Absolutely. I see that. Multi-sync over Wi-Fi works great. Wireless power would be beautiful. In the case of here, in the City Hall example of that show I assist with, it's not my show. It's actually a local high school robotics team designs and puts the show together. And I just help provide technical advice and assist with them. But they have plenty of power out there in the yards where they need to be. They just didn't have a way of running network cables across the top without creating public trip hazards. Yeah, Tesla devised wireless power a long time ago. Yep, absolutely. Look up Tesla coils. Anyway, so we're getting ready to take a look at the FPP configuration. Let me just go back to my status page on all these. I won't kill my drawer, my annotator. So this is the main Pi. You can see he's just wirelessly connected, or he's Ethernet connected, as we described earlier, to my my actual network. The Pi 3 is, I'm going to go back to the main Pi. This is the main Pi player. I wanted to showcase that from an output perspective, the main player in this case is not configured to output anything, right? So he has nothing on the network output, the E131 ArtNet DDP tab. That's network-based outputs. There's nothing configured here. There are no pixel strings for local pixels on this Raspberry Pi, no panels configured, and no other outputs. So this is just a player only with no outputs defined itself. So it's not going to send any data to anybody other than the multi-sync commands to communicate with FPP remote-based controllers. This is test Pi 3. He's set up down here at the bottom. You can see he's set up as an FPP remote. You also may note the difference in the status page. He's wirelessly connected to the primary network. And now I have Ethernet connected to this 103.10, which is what directly connects to the Falcon. Then we have the Pi 4, same configuration, right? It's in remote mode to listening for, waiting for multi-sync commands. Wirelessly connected to the primary network, and Ethernet is configured for a 101 network that connects to the Dragon. The test by zero, I'm not going to talk much about today because he's the same as the show a couple of weeks ago. He just has LED panels configured and he's just operating in remote mode off the primary network. So we have, this is where I got my P10 panel. You'll see in a second my camera view, and he's just wirelessly connected to the primary network, and he's just going to take commands directly on the primary network. No proxying or anything dealing with him. And we also want to demonstrate on these two proxies. Currently, I've got nothing defined for network outputs. Now, this guy, I do have a pi hat configured here, and we'll talk about that a little bit. This amber light is just a single channel. There's no pixels, but we'll talk a little bit about when we get to the GPIO output section. We'll talk a little bit about what that guy is. This is also related to that GPIO output, but there's no network output to the Falcon defined currently. Same on 4, there's no output defined for the Dragon. You know, these are not defined. We're going to push this from xLights to demonstrate the proper settings in FPP Connect that allow you to have each of those pies only get configured for their respective controllers instead of all controllers. That's a little bit about the current setup. I think that's all I wanted to really talk about there. Bonus section real quick. I happen to leave all my controllers in DHCP mode because I move things around for lab and demonstrations. I'm currently using, for ease of use, not that you would need to, an FPP 6 and newer. These guys are on 7 master. Under networking with the advanced UI setting, you can enable a DHCP server. So example, my Falcon controller is set to DHCP. And I'm using the DHCP server built inside FPP in order to serve DHCP on my show network. So the Falcon actually got his IP address from the DHCP server on the Pi, the FPP instance. When you communicate to a controller through proxy method, you also have to configure in FPP proxy settings so that he knows how to connect to that controller. Normally you'd come up here and add. When you're using the DHCP server built into FPP, he automatically adds any DHCP clients to the proxy host. So I did not have to manually add them in here because I'm using the DHCP server. Again, not something that everybody's going to use in every show, but you do have that option of servicing DHCP IP address assignment on a dedicated show network if you would need that functionality. So again, that's an optional feature that's now developed within FPP. So back in xLights. Any immediate questions on that quickly before we get to the next little set? Okay, don't hear of any. Feel free to continue to populate in chat if you need to. So example, on the Dragon controller, even though it's on one of those show networks, it's on the 101 show network. I can open and it actually goes through the proxy and looking at this output page, right? You can see my tree definitions and all that going through the proxy. So no different than just using a singular proxy. And the same with the Falcon. If I look at my Falcon, I can open the controller and I'm looking right at that controller page, routing through the proxy on that particular Pi, in this case, test Pi 3. Output settings, you can see I got some things identified down here on ports 15 and 16. In chat, bonus points, fictitious bonus points for anybody that can identify why I might be using ports 15 and 16 or the lower set of ports instead of the upper set of ports. Does anything happen to be configured on the FPP remote in order to function as a proxy? Right. So under traditional, just using FPP as a proxy, you would, and that was a question in chat, you would come to the status control menu, proxy settings page, then you would click add, and you'd put the IP address of your controller. If I had another controller here that was just like, I don't know, 103.25, and then save, now I've got that available here as a link. So that's just an additional link. So under a singular proxy server, you do have to come in manually today, status control proxy settings, and then you need to add your actual controller IPs in here. Again, in my demonstration, because I'm using the DHCP server, it automatically adds any DHCP clients automatically to this proxied host page. Hopefully that answers the question in chat successfully. If not, feel free to comment again. I don't really need that guy, so we're going to go ahead and delete him, and I'm going to refresh. Save, delete and save, right? Got to remember my steps. And he's going to want to form resubmit. That's fine. Continue. Boom. Now I don't have that extra proxy in there, so I don't need it. So the next key piece of this is to make sure that anything that's functioning as an FPP player or an FPP multi-sync remote in xLights, we want to make sure that those devices are configured as xLights only and for the active setting, not inactive. A controller defined as active means he's going to expect to actively receive data live over the network. So a lot of our traditional bridge mode type controllers, like your Falcons, your Genius, your Hinks, your Alphas, etc. But anything that's like functioning as an FPP remote, you want to make certain that you configure them as xLights only. And we talked more about that in the FPP basics class a couple weeks ago. So everything in here that's an FPP based device is configured to xLights only, and everything that is an actual live bridge mode controller. This demo, I've got the Falcon and the Dragon just to demonstrate different controller types. They're set to active, but everything else is set to xLights only. If you have a dedicated player, like we do in this demonstration, he's player, he doesn't do anything else. He does not even need to exist in this list, right? Because he's technically not a controller, he's just a player. In recent versions of xLights, but if you hit discover, he'll always find it. And that can cause you some channel conflict issues. So in recent versions of xLights, if you do have your player listed here, you can actually configure it as an FPP player only. And then xLights effectively just ignores it, and there's 0 channels assigned, and there's not going to be any conflict. One advantage of having that in here is if you just hit the open button, it's going to launch a browser directly to that instance, right? So it's okay if you have them in there now. We used to advise never have your player in here if it was a dedicated player, but now just configure it as a player only and you're perfectly fine. So part of the magic happens actually in FPP Connect. All right, so FPP Connect is the utility we use to upload configuration, sequences, and media files to all your FPP devices. So this has discovered my FPP devices. And no, that's all. I got the 4. I was thinking I was missing one, but no, I've only got 4, right? Now I'm going to talk about all of the details, but really this UDP out section is key, right? So UDP out is basically what configures your channel output page for EU131 and DDP data. So your network outputs are configured via UDP out. If you have a traditional show and all that, and you got a Pi or an FPP as your player, you probably want to set this to all so that guy would be test Pi 3 needs to be on proxied. Just pick the main player as an example of the player. If you want your player to output to all controllers, then all active controllers, then you hit all. If you want to configure what we're doing here with proxy mode, you can use the proxied. And what that means is it will only upload the outputs where this FPP instance is defined as the proxy. So if I did all on the main player, he would get the outputs for both the Dragon and the Falcon, but he would never be able to send data to him because the remote player does not have a direct network access to it, right? So we refer back to our drawing, the player has no direct access to the Falcon or the Dragon, right? I have to communicate through these other FPPs to get to them. There's no direct access. So if I put all for my player, he's going to get output defined that he cannot ever reach. So those outputs would be like, hey, I can't talk to those controllers. What's up? So when using proxies, specifically when using multiple proxies, you get in a complex trying to configure that output. But now that we have the proxied option for the UDP out, that solves that problem for us. So example, I'm just going to leave it. I'm not going to send the sequences again. I already have done that a couple times. So I'm just going to hit upload so I can send this configuration to all the FPP devices. Boom. And that's just it, that, right? So if you remember when we were looking at our remotes earlier, I've got my toolbar in the way. So test Pi 3, that's one of the proxies. Output configuration was blank. Now he's outputting to the Falcon and Falcon only. I don't see any other controllers. It's only the controllers that were defined to use this FPP as a proxy. In this case, the 3104. Now on test Pi 4, if I refresh this page, you can see this guy is now outputting to the Dragon because the Dragon was configured to use 30.70 as his proxy. So by using that UDP out proxied, xLights and FPP Connect is able to configure your outputs just for their respective controllers instead of all controllers. Hope that makes sense. I know we're going through that kind of quick. So any immediate questions on those quick subject we just went over? So to see this is working, I'm going to ask you to put your attention to my other account that's logged in with the camera. I'm just going to play this. I've got a couple of sequences loaded in here and a quick little playlist. I'm just going to play and we'll see that everything should be outputting. So the trees on the left are driven on the Dragon. The P10 panel on my chairs are driven by the remote Pi 0. The floods and the pixels on the table are driven by the Falcon. So we're able to get that show talking from the player to everything through the multiple proxies. Hopefully that sounds not too loud. It's away from me, but we'll go ahead and stop that. So that's just demonstration that our topology that we just set up with multiple proxies, talking to different directly connected controllers, outputting to different show elements. You can have that combination of whatever you need and still have a well-functioning show. Don't see any new questions in chat. Any questions on voice real quick over that? I think I'm going to wrap up that topic. So if people think of questions along the way, feel free to come back. I know we're going kind of quick, trying to maintain this for like an hour or so. And I know an hour and 15, and I've got like, 20 some minutes ago. Just realized my power is not plugged into the laptop. So I'm grabbing that power cable. I've got plenty of battery. So that's like the deeper one we got into. So let's get into inputs and outputs. So this is kind of what I got set up now on the test Pi 3 that was Dragon the Falcon. I've got a Genius input extender hat. Kind of right here. And then one of their input nodes. I'm using these RF relays. So it's a bank of 4. Let me zoom in here a little bit. A bank of 4 relays with a little key fob as my button. So instead of having physical buttons, I've got one of these little key fobs that's an RF key fob to these relays, and I'm using 4 relays for 4 different functions. That's for the input side that we'll talk about in a minute. Now, the Experience Lights hats, you don't have to use Experience Lights hats for inputs, right? It makes it very convenient and very helpful. I'm going to refer back to the manual real quick. So if I go back to the top of the manual, I'll find my table of contents here at the bottom. Down at the bottom here, the resources, there's actually a GPIO input button section in the manual. It talks about different pinouts and a whole bunch of topic on button inputs. You can do external resistors or your pull up or pull down. We won't go into great detail on that. We'll go through talk about the detail I have set up in my demo, but there's a lot of information here about pull up, pull down. Do using external resistors or internal resistors and different diagrams. So there's a whole section in here about GPIO inputs if you want more detailed information about GPIO inputs. Effectively, a GPIO is going to be either a low state, which is 0 voltage, or a high state, which will be 3.3 voltage. If you don't declare what it should be, it could float and be somewhere in the middle. So that's why we use a pull down resistor to set a GPIO to a 0 voltage setting or low setting. And we can use a pull up resistor to set the pin to a high 3.3 volt setting. So you can either switch to power or you can switch to ground, which will either pull the pin down by switching to ground, or you can pull the pin up by switching to power. So if you don't understand what we're talking about there for electricity and ups and downs and resistors, feel free to read this section or come back with detailed questions. We're not going to have time to really get into great details, but just a little description of what GPIO inputs are. So with the pi hat makes it easy. The experience lights in and out board and the input extender hat here both kind of switch to power. So therefore we will use a pull down internal resistor when we configure the input buttons, which are already configured. We'll go through that. In order to demonstrate GPIO outputs, how you can use a GPIO pin to trigger a relay, I've got another GPIO type screw hat here that I bought off of Amazon that physically plugs in the top of the experience boards. The experience boards have headers. When they plug onto the Pi, they also have headers on the top. So I'm able to stack this other GPIO screw terminal block on top of it to make easy connections to connect over to my relay. Be careful when addressing GPIO pins on Raspberry Pis directly, because it is easy to short a pin and cause a burnout and cause damage to that pin or the header or the entire Pi. So just make careful when you're making wire connections and all that you're being careful and not to over short something or overdraw current. Very little current can be drawn directly from the GPIO pins on the Pi. If you draw too much current, you're likely will destroy either the GPIO pin, the header, or the entire Pi. I'm using these other relays that I did buy off of Amazon as well. It's an opto isolated relay, which means that whatever's on that quote high voltage side, in this case, I'm just doing 12 volt, but that way it's optically isolated. So the 12 volt side of this relay can never backfeed into the GPIO pin. If you use just a random relay and somehow you accidentally get 12 volts onto that GPIO pin, you just toasted that GPIO pin likely. Ask me how I know. I have a Pi here that was done with. Not by my own account, but somebody I was helping and they said, oh no, don't do that. Anyway, so for an output, we're going to drive off this GPIO and drive this little 12 volt LED that I have here. This is just like a marker light for like a vehicle or something. I had one of those handy. It can be anything that you're driving off the relay, as long as it's based on the input voltage to the relay is where it will send output voltage, and you just need to make sure about the relay there. I took a look at what GPIO pins are used on the experience lights hat. And then I determined what GPIO pin I wanted to use for my output. You do not want to use the same. You cannot use the same GPIO for input and output, but I choose never to use any of these GPIO pins for outputs if I'm using an experience lights hat. So I happen to choose, and we'll show this in a little bit, GPIO4, which happens to be on pin 7 in this. Let me see if I can get my highlighter working again. So GPIO4 happens to be pin 7. So my relay is actually connected to GPIO4 on my little header. That's just the physical wiring aspect of what I got for a GPIO output, and then the configuration for GPIO inputs. I happen to choose to use, just because my my input extender node, I was only using 4. I'm trying to zoom again. Sorry, apologize about the jumping around. So I'm using the pin number 1, which will be GPIO 17, pin number 3, which is GPIO 27, pin number 4, and pin number 5. So I'm going 1, 3, 4, 5, 17, 27, 22, and 23. That's what I'm using for my input configuration. It's all marked right on the hat. And I'm using 4 for the output. So let's talk outputs for a second. Let me get back to my. So in FPP, you have FPP commands, so you can run a whole set of base FPP commands. Right, so to trigger a GPIO output, you can use the FPP command called GPIO. You have to specify which pin. Now this is the pin number, not the GPIO number. So we just looked at GPIO 4 is pin number 7. So I'm going to say pin number 7, and I'm going to say set that to on, which would be a high state. Now, again, if you draw your attention to my table, the camera view on the table, I've got that LED light. We just talked about the little yellow LED light, this 12 volt. I'm going to say run now, and that light should turn on. You should see a little yellow light. If I untick this, run now, turns off. So on sets the pin to high, which triggers the relay, which then outputs up the relay outputs to the light. Off, turns it off. See a couple of hats here. Quick, create a group from the layout. Yep, couple of chat messages are not related to the class, so that's perfectly fine. So, yep. So remembering which pin you have to get to, and remembering every time I wanted to trigger that, I'd have to do an FPP command. Now we can add FPP commands and playlists. We can do lots of things with FPP commands. But I'd have to remember now, wait a minute, which pin was that again? And it was this pin was that, and this pin was something else. And so so that can be complex to trigger a GPIO command every time. So an FPP's got a concept called command presets. So in command presets, we can define some FPP command with a name that you make up, and then you can call that preset. So you don't have to remember all of the parameters for your command. If you have a command that takes multiple parameters, you can configure it as a preset and then give it a name. And we're going to talk a little bit more on presets in a minute. We'll talk about slots and stuff, but in this example, I've got the amber on, which sets the, if I edit this, it's just the GPIO pin 7 on. And then the amber off is just a GPIO pin 7 unchecked or off. So I can say run now to turn the light on. I look over, the light's on, say run now, lights off. So command presets are a way to real easily recall a command that has multiple parameters without having to remember all the parameters. I'm click. Yeah, that's it. So I think that's all I want to talk about. Presets right now. We have some other preset conversations when we get to GPIO inputs. Any real questions about GPIO outputs? I remember a question somebody asked me, apologize. Can I use that GPIO output in a sequence? Right, so I'm going to go to my channel outputs on this guy. Remember, I was on other, and I added another output, selected the type. There are multiple types of outputs that FPP supports. Right now, I'm going to refresh this page, and we're going to talk about the GPIO output type. I can assign it a starting channel. In the case of a GPIO output type, it's going to be a single channel, give it a description, and I can assign it the GPIO pin. Inverted means that you go backwards. So right now, without inverted, if I turn on through xLights or through a sequence to this channel 8695, then it will go high. If I invert it, then when I turn it on in xLights, it goes low. Our configuration here, we want to go high to trigger the relay, so we're not using inverted. I'm going to go ahead and enable this output right now, hit save and then restart. Now I've got this output called 8695. As you restart this, go to xLights, sequencer, I start the layout. I got everything set up. I set up a basically a single channel model. In this case, it's a channel block model type set to one channel. I named him Amber Light, and I made sure that he was associated with the controller in this such that he got this IP, this channel number 8695. So I've got a model that's a single channel model, model 8695. Sequencer tab, let's create a quick animation sequence. And find where my amber light is. So just grab an on effect. Now when I output the lights, that light's on. So I am now with this on effect. Let me move it to something else for a second. Coming from xLights. Right now it's on my star left over on the mini tree, just on. If I move it to the amber light, it's outputting from a sequence to that model 8695, going to the FPP device 8695 to the GPIO pin 4. So that can be used for other, devices you can control with the relay, and it could be a 110-volt relay that you set up. Maybe you had 110 relays from previous projects that you wanted to drive AC things. So this would be a very poor way. I won't say a very poor way. This will be just another method to drive relays or other items that you can switch high and low with the GPIO pin. Any quick questions on GPIO outputs?
One thing I wanted to mention on that is with FPP 7, you don't need to create those channel blocks now. You can just do it directly from the sequencer in xLights.
There's some advanced things with the slight the slight change to the FSEQ format that allows you to do FPP commands directly within your sequence. So in FPP 7 and modern xLights, you can actually do FPP commands direct from a sequence, and that could be trigger a command preset to be able to turn light on and off. So great point, Rick. Yep. So they're just new advancements that are always coming in the software because of the rapid development cycles, right? I'm actually going to that I got that running through xLights. So let me go ahead and quit outputting the lights. I'll turn that off. Will that be including your countdown timer? Yes. And I think the other chats were not class related, so I'll leave that go. And just for the sake of everything else I got going on, I'm just going to disable that output for now. I just wanted to demonstrate how you could sequence to a GPIO output, direct GPIO output in FPP. Inputs. Under input output setup, GPIO inputs. Touch base real quick. So multiple proxies we talked a lot about. GPIO outputs, a little bit about command presets. Now we're moving into GPIO inputs, right? So this is where we go to configure our GPIO inputs. And if you're using an internal resistor, you can define whether you want that to be a pull up or pull down. If you're following the manual and using your own resistor network and your own electrical configuration, then you would want to leave this on none external resistors. This is your pull up, pull down method. And since we're using the Experience Lights hat for our button triggers, they switch to voltage, so they switch high. So we want to put the steady state pull down. I put a description in here for my button. So we're using GPIO number 17, which is pin 11. We don't care about pins because we're using the hat. GPIO 17 is my A button. GPIO 27 is my B, 22 is my C, 23 is my D. So I just mark those in the description so I know which button does what. Then you can run a command. So on whatever GPIO input you trigger, you have the full set of FPP commands available to you again, right? So one thing I wanted to set up is I want to start my show from this button. Now remember, this is an FPP remote. So down here at the bottom, he is a remote. He's not the show player, but maybe I want to start my show from a button. So I'm going to choose the command called remote playlist start. Then I get to pick and choose, well, if it's a remote action, which IP address is going to do that. This will automatically show out of the gate any of your discovered FPP devices, so you can just pick it. In this case, my main Pi is the player that I wanted the playlist to start, and I named the playlist called Zoom Class. I'm going to let that playlist run on a loop. So those will be manually triggered on a loop, not according to a schedule. Manually triggered on a loop. And in this case, I want to make sure and do it if not running. These options will vary depending upon what command you select. If not running just means that I push the button once, it starts it. So it's running. If I push it again, it restarts it. If I push it again, it restarts it. That's not the behavior we want. So we're going to choose the if not running. So it will only start the playlist if the playlist is not already running. If that makes sense. Now for my second button, I decided to do this remote trigger command preset. Also on this main Pi device, I want to do a stop all because I want the ability to stop the whole show. So I want to start the playlist and I want to stop everything. Those are the two buttons that I chose for this demonstration. For my third button, I decided I was going to trigger a command preset. You're going to notice it's not a remote. It's just trigger a command preset. And the preset name I'm using is Amber On. So that's defined on this FPP device. If I go back to command presets, you can see I got Amber On and Amber Off. If I go back to my GPIO inputs, and I'm going to trigger a command preset, I can say Amber On and Amber Off. These left and right, I'll talk about that in just a second as soon as I finish this last input. So this fourth button, I decided let's do an FSCQ effect start. There is a difference between effect start and FSCQ effect start. So in xLights, you can create an effect that's an ESEQ file instead of an FSEQ file, which is an effect file. And you can do that really easily, generate that from xLights if it's a singular model. So I got a singular model. You can right click the model and you can then go to export it as an effect file. Then you can upload that with the FPP Connect and you can do an effect start. In my case, I've got this floods FSCQ. So I'm using an FSCQ effect start, which allows me to choose my FSCQs. If I did just effect start, it would only allow me to choose ESEQs, which just don't exist on my instance here today. So I'm doing an FSCQ start. I'm not going to go into great detail on the differences. Just know that there is a difference. I'm just going to refresh this page since I didn't make any save changes. So that's going to be an effect start. So when you're doing input triggers, there's a concept of rising edge and falling edge. Rising edge is the action of going from a low voltage on the GPIO to a high voltage. It rose up. So it went from a 0 voltage to a positive voltage. That's a rising edge. Falling edge is when I go from a high voltage to a low voltage. That's the falling edge. If you notice, those are paying attention on my button C here. I did an Amber On the rising edge. So if I'm going to go from low, I'm going to push the button and hold the button. It's going to go high. When I let go of the button, it goes low and it's going to do an Amber Off. This has the net effect of like a momentary button, right? So I can take I got my little keypad. Let me do my other video here. Maybe you can see me. Hello, everyone. Got my little keypad here. And if I push the D button, that's going to trigger that GPIO input. Oh, that's going to start the floods. It's the C I want to use, right? So the C button, I push and hold, the light's on. I let go, lights off. So it has a momentary button effect by configuring something on the rising edge and also the lowering edge, the falling edge. It gives you a momentary option where it only is high for the duration you hold it. Let's go ahead and trigger my effects here, right? So floods, I got a standard flood. It's just a bars effect on my floods. You should be able to see the floods going through all the colors. It's interesting to note that the small flood that you can probably see, I don't know, they're kind of side by side, is a DMX controlled flood. The left flood is actually a 4-channel WRGB flood. And they're always the same color because they're configured as, that one's configured as a 4-channel model, not as a standard RGB model. It's configured as a WRGB model. And then I can push my B, which is my stop all. So that stopped it. Now that was an effect. You can also see that from status control effects tab. When you play an effect, you can see the effect is running here. And then I'm going to push the button again to stop the effect, to do the stop all, and it stops the effects. So on the inputs, that stop is doing a remote trigger stop all, right? Well, what is that? Well, let's take a look at that main pie and let's see. So we'll go back to the main pie. It is status control command presets. I've got several defined. So I've got one command preset that's just a stop now. Just a stop now command, which will stop any running sequences on this pie. If I edit that, you'll notice I also tripped the multicast. So this command now will say, do stop now, and send that message via network multicast to anybody that's listening to do a stop now. So any FPP device that responds to multicast should do a stop now also. So we're actually saying stop now on all devices is kind of how that translates. But that doesn't stop effects, right? Because effects are not sequences and they're not playlists, right? So I got another command preset that says effects stop now, and I'm also multicasting that effects stop now. So this is running on the main pie, but you just saw that when I push the button that's connected to the test pie 3, his effects stop because he received this effect stop command through multicast. But he didn't receive the stop effects command, he received the stop all. So another FPP command that we have is to be able to trigger multiple command presets. So you can either trigger multiple presets by a slot or multiple command presets. Slot is just a number that you assign here. So in this case, I chose slots. So I'm going to trigger slots. Let me edit that. I'm going to trigger slots 1 and 2. There's only 4 that I can do when doing slots. So I'm going to trigger slots 1 and 2, which happens to be the stop now and the stop effects. So with this one command preset, I can perform both of those actions of stopping all playlists via multicast and stop all effects via multicast. One of the things about preset slot numbers you can read about, because you can sequence using a control channel. So I'm going to talk about FPP 6 and older. So in FPP 4 and older, had events, and there's like a minor event and a major event, and you had to figure all that out. So command presets took the place of events in FPP 4. So command presets, you can define a control channel and you can send a specific value from your sequence to that control channel, and that would be a slot. So if I defined a control channel here to be, say, 10,000, and then I sent it the value of 1, it would run stop now. If I sent it the value of 2, it would run stop effects. Now in FPP 7, the whole way that they do the control channel for command presets is changing, and you're going to have the ability to, and it's going to be defined within xLights in the FSEQ, because there's a minor version change with FSEQ format. You actually be able to configure the command preset commands and have multiple control channels. So instead of just be limited to 256 values on a singular control channel, now you'll be able to use multiple control channels and have multiple values. And so you can just trigger more events to happen. It's all about bringing in a higher scale of automation and interactivity potentially, right? So that, I think that kind of wraps up command. One other thing about command presets. So one of the things people want to know sometimes, I want to plug my FPP and I want it to start the show, right? Maybe I've got like something I want to put on my truck or a parade float, or hey, I put up a tree in a park, but I just want to be able to get power on and have it automatically start. Well, in the old days, you used to set a schedule from like, midnight to midnight. So you set a schedule around the clock. And with command presets, once I add a command preset, you have a predefined set of triggers that you can choose. So you can type in your own, I'm going to call this thing Zoom sample, and I can create a command preset called Zoom sample. Or I can choose one of these predefined things. So when the like 5 minutes after a playlist start, I can run a certain command. Actually, that's before. It's playlist start minus. So like 20 minutes before my playlist starts, I can then run a command, right? But the one that's most commonly used is FPPD started. FPPD started, and do like start playlist. We're going to choose the playlist. I can do that same. I want to repeat the playlist forever, or I can, if you're doing like a standalone show, maybe you want these options. Just repeat it and play it as long as there's power. If I go ahead and accept those changes, save, it's going to ask me to restart. Now, if you watch the camera, as soon as I restart, my playlist is going to get started. Boom, playlist started. I didn't have to worry about setting up a schedule or anything. It just automatically starts the playlist every time I start FPP. And we'll demonstrate that. So I'll manually stop FPP. Right, so FPPD is not running anymore at all. I'm not going to touch the playlist. I'm just going to start FPPD. And as soon as it starts, the playlist started. So you can see everything showing up on the camera, and the playlist started automatically. That's the new method with FPP5 and newer that you can set up to auto start a show if you need to auto start a show, all through command presets. I don't really want to stop FPPD. I want to actually stop just that. So I'm going to delete this for now. Restart FPPD, get back into normal operation. Cool. So following our list of topics, that kind of completes command presets and GPIO inputs. Any real interesting questions or anything on GPIO inputs?
Ron, is it worth mentioning that you showed that a playlist stop command where you can multicast it out? Is it worth mentioning though to people that multicast sometimes doesn't behave well on in Wi-Fi and jumping over certain access points, that you might have to use a unicast session?
Correct. So like if I go to status control multi-sync, now let's make sure I'm not confused multi-sync versus multicast. Multi-sync is the protocol used between FPP type devices for that whole player/remote functionality. Multicast is a network communication method. There's unicast, which means I want to talk to a specific IP address. Multicast is like, I'm just going to send a command out to the network for anybody who's listening. So it's like shouting down the hallway at your kids. I'm going to shout down the hallway, dinner's ready. Hopefully all your kids hear you, then they come to dinner. But maybe one kid's got his headphones on and he doesn't hear you. So you get like two kids coming to dinner, but one that's not. So multicast is more of shouting down the hallway at your kids. And there's also broadcast, which is more like shouting to the entire neighborhood, right? Broadcast goes to everything. Multicast is a targeted group of things that are configured to listen. On some Wi-Fi networks, specifically, we see this with some of the mesh systems. They don't propagate multicast very well because if you're connected to one of those remote nodes, it might not hear the shouting down the hall. So in the event of multi-sync, if you have like a remote that's not responding well, and maybe all your others started working and the others didn't, then it might be multicast. So you can always come into the checkboxes on your player. Again, we're on the main Pi player. And you'll see your remotes. And there's a reason these are shown unknown. We can talk about it if you want to ask, because in FPP6, when you have multiple IP addresses, because both of these are proxies, when they have multiple IP addresses, it's going to try to discover it on all IP addresses. So it's unreachable on this one address. So it'll show unreachable here because there's an address that's unreachable. In FPP7, that changed. I know I jumped topics slightly, but in FPP7, that's been different. If you can reach any of the addresses, then you'll show the status. It's not reach all, it's reach any. So in FPP7, you won't see that anymore. But in FPP6, you may see some of your remotes unknown, especially if you have multiple addresses where one's not reachable by the player. But if you wanted to converts to unicast to send targeted packets to each remote, you would just check these boxes, right? Next to each of your remotes. So I want to send commands to each of these remotes. You'll notice this warning message saying having unicast with multicast is discouraged, because now you're going to send both. So you'll want to come down to your settings button in that scenario and uncheck multicast. Now these three are all set up to unicast on those specific reachable addresses. And that auto saves when you make those check marks. So we'll just let that auto save and I'll hit, restart a PPD. So now I'm communicating from the player to the remotes in unicast. Now, if I do an FPP command, and it's going to be like some command that I want to send to everybody, you multicast, but then you get like host available that you can pick and choose, and you can start, I want to send this. You'd have to copy and do a comma. So you can do comma and then your next one. So you can, if you're having problems with multicast, you can put each of your IP addresses in this host field separated by a comma, and then you'll have better luck with multicast. But that's some networks that don't, tolerate multicast very well. A good point, Pat. Thanks for that. So one of the things about FPP, so the last two topics we're going to touch on is plugins and scripts, right? I want to hit my button, just make sure everything's, so change that to unicast, make sure everything's still working. So I see floods, LED panels, trees, I see pixels on the table, so everything's still working. Now that I set it to unicast, everything's still communicating out. Is that FPP is quite featureful. There's lots of features, there's lots of functionality. You may not choose to use all that functionality we've discussed tonight, or even other functionality. But let's say there's something that wants to be accomplished that's not part of the FPP application. There's a concept of a plugin manager and plugins. I think I removed it. Yeah, cool. So there's various plugins that have been written by other developers that are designed to plug in to add additional functionality into FPP. Just on the top here, there's like an after hours music player plugin that you can choose to install and configure. And basically you can have that set up so that when your show's not running, your FM transmitter might be rebroadcasting some internet radio station. So maybe you find like a Christmas music internet radio station that you would like to have broadcast on your FM transmitter that's not during your show time. And so you could use that plugin to accomplish that. I'm going to do a quick search here for big buttons. So I use this big buttons pretty regular. So I'm going to select this, this plugin and install it. So we're going to install the plugin. And it's going to go out and talk to the GitHub where that plugin is stored out in the GitHub repositories, and then install it. So now it's done. And you'll notice that once the plugin's installed, it'll be at the top of your list and it turns green and it says installed. You can update now, or you can check for updates if you need to, or you can uninstall it. The big buttons requires a configuration. So now under status control, and you now see, actually it's under content setup where you're going to configure it. So content setup, configure big buttons, and then status control is where you're going to see the big buttons. And I'll give a use case for that. So just configure a couple of quick buttons here real quick. So I went to content setup, configure big buttons. I can create multiple tabs and I can add multiple buttons. Basically, we're going to name a button and just say this is show start. I'm going to select a command. In this case, I'm going to say start playlist, Zoom class. Let's go ahead and repeat it overall, and only if it's not running. So if you push the button, it's already running, don't do anything. Boom. Just like we did for command presets and all. You can come up here and change the color. Maybe I want this button to be more of a green color. So I didn't hit OK. Except that's a very bright green. Sorry about that. It's still going to be a bright green anyway. And then you can give an icon. You can go select a different icon if you want for the buttons. I'm not going to get into all that. Don't need to worry about that. Then let's add another button. And you can change size of buttons or size of the text. that you see. You can change the background color of your page, but let's add a second button and then just call this guy stop all. Right now. Any FPP command or command preset you can call with these buttons. And you can give it a name, right? So I said, how about show stop, right? Whatever. And then let's go ahead and save our buttons. And you can actually rename this and just say show control. And then maybe I'm going to put like a volume button in here, right? So they just say volume. Whatever you want. Let's add a button and let's say the command. Then we go back and edit it because I clicked away from it. Right down here, settings, and do like volume adjust. Isn't there a volume increase maybe? So let's say volume increase by 20%, and call that volume up. Then add another button that maybe I want to say a volume decrease, and say 20%. And name that one volume down. And you can change these colors, right? We already demonstrated that, but for the sake of speed, I'm going to not worry about that. So we just saved our buttons. Now, how do you use the buttons? Well, let's come up here to status control big buttons. I'm going to right click and open in a new tab, right? That way, just get a new tab with my buttons, and you'll see up here, it's titled show control. So now I get a new web page with just buttons with show control. And I got tabs up here at the top called volume. So I can do volume up, volume down, show control start. So let's say I'll start the show. My playlist just started, it's playing, and then I can do show stop. I just did a stop now. If I go to volume, so on my main player status page, right now the volume set at 81, right? And 10 for that. But let's say I go to volume and do volume down one time. It should be now at 61. I can do volume down again. It should now be at like 41. And I can go do a volume up, volume up, volume up. And now it should probably be maxed out, right? So you can control your buttons. I use this on my phone with a handful of different buttons. And then you just go to FPP on the phone and then go to the status control configure buttons page. Or not configure buttons, but I apologize. So if I go to status control big buttons, then that page automatically changes to my button page. And then I'll mark that as a bookmark. Right? So then anytime I want, I can pull up my phone, go to my bookmarks, and I'm looking right at this where I can maybe I can turn the volume down a little bit, right? Because maybe it was a little bit loud. So now that's why I did open in a tab, because I still want to be able to come back to the main pipe page. So I just turn the volume down. So that way from my phone, I can control different functionality within FPP using the big buttons, and I can create as many buttons that I want on each page. I create multiple pages and multiple buttons on each page. So that's just an example of the big buttons plugin and the plugin. So the plugins allow us to be able to add functionality by, some creative developer. There's another one here called Simple Countdown that you guys can go take a look at. Simple Countdown plugin that you can grab and install. We were messing with that right before class. But there's all kinds of different plugins to provide additional functionality in FPP. Lastly, there's also a script repository for a bunch of other scripts. I will say some of these scripts were developed long ago, and some of them may not be compatible with current versions of FPP. But you can even, like there's a script that I used and modified, and there's no search here. So I'm going to do Control F to use my browser search and say random. There's a script called Cycle Random Sequences that I actually took that script. You can view the script. So if you have any kind of Linux bash scripting ability, you can actually write your own custom scripts for additional functionality and install them. Then you can use the FPP command to run your script. So I had a version of this I modified for a specific Halloween show that I took the script and I made the modifications I needed to. And then I had a command preset to run the script. And then I used my GPIO input button to execute that trigger command preset, which then ran my script, which started cycling random sequences. So there's a lot of extensibility and ability to add additional functionality through either plugins, which is a developed plugin, or a script, which is just Linux scripting. That kind of ends the primary content that I had planned for today. I think we got through all of these topics. I know we spent more time on multiple proxies, but that was a pretty advanced topic. You don't have to do any of these things in your show if you don't want to, just trying to give a demonstration of what is available to. And I just realized my camera is still on here, so I am making lots of faces, right? Good thing I wasn't picking on it. Sorry. So is there any questions or any other topics we might look forward to including in a future gem session? And don't feel bad if a lot of the topics we talked about, we kind of went through quickly. If it's kind of over your head, I don't really understand that. That's perfectly okay, because I know we went through a lot of content quickly.
Ron, I don't think you went over the output processors, and someone's asking about it.
Oh, perfect. Yeah, you're correct. I did skip over that one. I apologize about that. So in FPP, there are some other functions called output processor and input output setup output processors. So this just has a way of manipulating the FPP output. And then if you are going to add a processor, you're going to get a type. So you can do a channel remap. You can do an output processor for brightness. You can set the brightness for a specific. You can define this as a channel for brightness. So you can actually, within your sequence, you can trigger on a specific channel a processor to adjust brightness on FPP. Now, mind you, that's everything on that FPP all at once, right? I don't particularly use that output processor. That's just an example of one. The channel remap, you can hold a particular value. You can reorder colors. You can convert from the 3-channel to 4-channel for those WRGB items. You can define that on specific channels. What's the starting channel that you want to go from 3 to 4? What's the how many nodes and what color order do you want? So some of the 4-channel items that were available before xLights really supported 4-channel, clearly you had to do a output processor to adjust that. Raspberry Pi pixel output up until FPP 7 did not support 4-channel. So if you're doing like a Pi hat to control pixels and you wanted to control 4-channel, then you likely would need to use this 3 to 4 output processor. But specifically, I want to talk about remap, and I'm going to do that on TestPy 3. I'm going to get rid of that. Sorry. Oops, go away. That's my work event that we actually pushed to 9 o'clock. It's just giving me a warning because the event was scheduled for 8:30. So on this FPP, I've got a particular sequence. I'm going to look at my outputs. So my Falcon is starting on output 8696. So I've got an output 8696 for 456 channels. It's what's configured. But I've got a sequence that was created that I know the content of the sequence is really channel 1039. So this was frequently used if you had to move a model from one controller to another controller, but you didn't want to redo your sequences. So you know that that model starts at channel 8696 and it's 100 pixels or 300 channels. And I moved it from controller A to controller B. And I know in this sequence that model's represented starting at channel 1039. So I want the content of the sequence, channel 1039, for 300 channels to now output channel 8696. So to demonstrate that, I want to convert this guy to player. Oops, player. Go to status control. And it happens to be this all butterfly sequence because everybody has an all butterfly sequence, right? So I converted to player just so I could play this sequence. So I'm going to hit play, and nothing is outputting anywhere on my table. Nothing is outputting anywhere in my show. And I'm like, well, wait, I know that that has what I want. Why is it not outputting? Well, because maybe I moved my model and it's a different channel now. So let me go to output processors. And I'm going to choose a channel remap. I'm going to say the source channel that's in the sequence is 1039. My destination, oh, I do want it to be 8699. So let me look at my Falcon. I've got that open here real quick. So really it's this 100 line. Remember on my Falcon, I had some DMX. I don't want to leave. Go to serial. So my, yep, that's fine. So my DMX starts at 8696 for 3 channels because I just got that one RGB flood on DMX. So I know my model that I really want that sequence to play on is this 100 line model starting at 8699. So I'm going to take what's in this sequence on 1039. I'm going to output that on 8699, and I want 300 channels. But I don't really want it to loop. I just want whenever the sequence plays those channels. So it's channel remapping. Basically 1039 becomes 8699, 1040 becomes 86, or that'd be 8700, and etc. I'm going to go ahead and activate this channel remap. Save, restart FPPD. So now I have that active. So now when I go to play that sequence, anything that's on 1039 or up to 1339 should now start at this actual output, which is on my Falcon controllers. Now, if I go back to status page, how about if I play, oh, look, that 100 line bundle of pixels on my table is now playing that butterfly sequence. So that's an example of using a channel remap output processor to modify the content, to take what the specific channels in a sequence and then output them to different channels configured on your controller. Hope that kind of makes sense, but there's other output processor types available that that you can see here, like a brightness we talked about, set value, hold value. You can set values on certain channels to certain values if you wanted to just use that. You can reorder colors in case everything is RGB, but you really need it to be GBR. I would recommend other methods for channel order handling rather than an output processor, but this can come in handy if I used this on a real show in Iowa at an old folks home 2 years ago. It was all AC show, and one of the fuses blew on the output of one of the Lightorama controllers. So I moved it over to the Lynx Express controller, and I just did a channel remap for that one channel and said everything that was on channel 8 is now on channel 36 or whatever it was. And I didn't have to do any sequence adjusting or anything, and that was remote. So that's an example of doing a channel remap in output processors. Hopefully that makes sense. Yep, and thanks, Don, for that. Yeah, did you miss it? Yeah, I skipped over that because trying to expedite. So any other content? If anyone thinks of things they'd like to see, feel free to reach out here in the Zoom room and let somebody know. There's helpers in here 24/7. If they can't answer it, they certainly know how to get a hold of me. We're a pretty good group and we communicate behind the scenes. Or through the FPP Facebook group, right? There's always the FPP Facebook group. If you want to pose your question publicly, you might get 4 or 5 different responses out there, right? So depending on everybody's experience. Yeah, any other topics? Or are we ready to pretty much close out? Hour and a half. Look at that. I didn't go 2 hours. That was my goal. Do not go 2 hours.
All right, I want to thank you for that. Covered a lot of nice features that's in FPP, and we'll see how many people want to start using them. Thank you again.